Hello. So the question here is quite important because if the cloud becomes the norm, then the design will become the norm. And that will affect the location of where the data center will sit. But what is for sure is the region is lighting up. We're seeing heavy investors and global brands investing in the Nordic zone. I know Iceland has been mentioned a couple of times in the morning. It's a very little known fact, but they are a free cooling zone. Around the Reykjavik area, it's never been hotter or colder than current ASHRAE standards as it stands. And in the west, it has some of the most stable rock within Europe. So there's a lot of talk about Iceland. I don't think their case has been argued in a more favourable way. But the Nordic zone, we've seen Google, Yandex, Facebook. We've seen many co-location companies coming to the south. We've seen mergers and acquisitions. This area is actually lighting up. And if you look at what is driving this, well, I think you can sum it up with when I went to school with a book and access to a library. But my children went to school with a laptop and access to the net. And that's in one generation. And this is what's driving the lighting up. And we're here at a bit of a meeting point. And this is the actual border between Norway, Sweden and Finland. And what they share are these common parts. The location is very stable, the fiber's great here, and the climate helps reduce the OPEX cost. In terms of power, we've heard many times here, it is very green, and the further north, the greener it actually gets. The Nordic grid, the actual ability to start moving power from one nation state to the other to meet capacity needs is extremely rare. I can't think of anywhere where nation states share a grid in such an open, free way. And the power prices are very competitive too. We'll come onto that in a tick. But also from a business point of view, you have market reach from the Nordics to 800 million people. Investments are safe. If I'm a foreign direct investor, this is one of the safest areas you can put your money into in terms of state risk. And I think if you look at the World Economic Forum rankings, the Nordic countries seem to always be in the top 10. So this lighting up, what is it? Well, if the internet was a person and it was a trillion pages of A4 big, 37,000 kilometre square would be the area. I think the internet has more than a trillion, but I'm just trying to give you the scale of if it was a person, this is what this is the size it would actually be. And in terms of power, the big debate is how much power does the internet take? Well, it ranges really. The lower numbers 170, the higher numbers 307, but that's everything. Arctic Fibre is a Canadian consortium, and they're planning to take advantage of the ice sheet moving north in the summer, so they can lay fibre when the ice retreats, and that's from London to Tokyo. Part of that drive is the Canadian government is putting into law that no government services will pass through the US. If you look at Rotax, that's a Russian company, also linking Tokyo to London. want to take advantage of the financial markets and faster routes into the east. The very first phase just tips into the north of Russia, close to the Finnish border, and the second phase will close into London and into Reykjavik. Emerald, which is being laid now, finishes that loop from Canada into Iceland to Ireland to France. What you're seeing here is a new loop being formed. This is a substantial investment. The other Nordic advantage is power, and we've heard a lot here, but competitive prices within the Nordics are a given now. Long-term pricing incentives, I think you can cut a deal 5, 10 years, sometimes I've heard 15 years at very competitive rates. I don't think I know anywhere which will give you a 10 to 15 year deal. As I mentioned, the further north, the more green it actually is with hydro wind. The security of supply is becoming more and more important now because the cloud providers are looking at not having generator sets and may not even have UPSs in the future. So the security of the grid is becoming more and more key. And Ian, I think that's just for you, the green grid. So if we look, what does power pricing means? Because I think after fibre and tax, that's number 3 on everybody's list. So Finland recently announced a reduction in tax on power for over 5 megawatt data centre. I think that certainly made the Swedes and the rest of the Nordics sit up and look at what that actually means for them. Sweden has a policy of the further north you actually go, you actually move into tariff bands and you get more tax advantages on power and the investment tax release the further north you go. Iceland probably has the lowest energy cost and the greenest energy in Europe. That geothermal's good until the Earth's core runs cold, so that's long enough. And Norway currently has the world's most efficient site, but more importantly for them, they're gunning for London, and they're saying they can supply an OPEX cost that's 40% less than the UK. So I'm just trying to give you some examples of the competitive advantage that the Nordic region has. So just moving into the design of a cloud data center, you're not supposed to have all 3. You're not supposed to have low capex costs, increased efficiency with a lower OPEX, and a faster speed to build. The traditional thinking is you have to give one of those away. Well, that's no longer the case when it comes to cloud data center design. And here's some proof within the north. Hamina site, very efficient. Is it now 120 megawatts now and growing fast? Absolutely huge. The Facebook site in Luleå, 140 megawatts, another 140 being built now. The interesting thing here is the convergence in the designs. The basic principles are becoming more similar, and I think you're going to see this as the years roll along. And even on the inside now, this is inside Facebook Data Center in the US, and what you'll see is there's no raised floor, where a traditional site would have a raised floor, a lot more infrastructure put in place. This is very, very thin, with common parts and non-common parts. But those non-common parts will become the norm. Their racks, I think, are much higher than the industry standard. I think that's the same for Google and a number of other cloud providers in the web giant space. Now, I think the birth happened here. 2009-10. I think this is the world's first true multi-megawatt free air-cooled design from scratch. It's called the chicken coop because of the shape of the buildings. And each of these buildings is a 3 megawatt module. Note the word module. It's a modular site. And you build in three megawatt chunks. 100% hydro powered from Niagara Falls. It's showing the template here of how the thinking is beginning to change. And this was completed in 2010, and it had sub 1.1 PUE numbers. And from the spade going into the ground to a server running a service, less than six months. Now, at the time, in 2010, you weren't supposed to have that, and this site was live in 2010. And the traditional thinking at the time was this. It should take you a year to build, not 6 months to build. It should cost you $10 million a megawatt. This was just about less than 5, so half. And the efficiency, more than twice as efficient on the PUE number. So the message here is, this is the proof that these sites have been running for 4 years. The metrics, the evidence is actually here. This is real. So we're moving into the commoditization of the data center itself, where the service is becoming a little bit more like a utility. So is there a catch? Well, yes, because when you go very thin and you halve that cost and you increase the efficiency and the capex is low, you have to understand everything about that space. Because I remember in 2010 taking people around that site, and they would say, when are you going to finish? And I said, well, it is actually finished. There's only what you need here. That's why the cost is half what you think you should be spending. But there is an actual catch, because you have to understand everything about the building, how it operates, how it runs, how the equipment integrates and also interfaces, and a deep operational understanding. Because with free air cooled, you've got to understand the weather, and you've got to be able to predict the actual weather. And the data gathering becomes more and more important, because as you run through a year, you can tune the efficiency to a much greater extent. So the whole DCIM information gathering becomes crucial when the infrastructure is thin. So how do you get over the risk of these proven Formula One design type data center? It's a little bit like cars, you know. The Formula One guys, they invest in research and development, they come up with some brand new tricks, and they end up in the family car. Not that my family car goes as fast as a Formula One car, but they do actually filter down. So how do you take the risk out of these new cloud designs? Well, because there's a track record of cloud-based designs, you can go for reference designs. You know, proof of concepts, proof of design that are already in place, whether you're a corporate company wanting to take advantages of cloud and the metrics that it gives, whether you're a modular-based company, it's a pay-as-you grow, or whether you're a very large, I think that bottom one there's a 20 megawatt site. These principles are known and tested, so you can seek external advice on how you de-risk your design. So what's influencing design and architecture now? Well, basically cloud is saying you're moving your capex cost into opex. That's the single biggest change for business. And for the providers, the cloud providers are the outsource as a service model now. And there's no reason why maybe 80% of everything we actually do possibly could go into the cloud. And there's probably 20% of the services and operations corporates have that they probably do want to still hug the server. So I want to show you a few examples of some of the larger cloud companies. Microsoft have got a change in thinking now. They used to be very good at showing you how they've been brilliant at building sites. Now they're looking to the future and saying we're changing the concept of how we design the building. We're going to accept there will be failure, and it's how you manage the failure that's coming more important. Now, that actually means for a company like Microsoft, they have the ability to use multiple sites in multiple locations and the ability to move the services and data from one location to the other. So they will say, well, I don't need any generator sets. If I don't need a generator set, I've either got to have a very strong grid, which the Nordic gives, or I generate my standby power or primary power on site. They're also looking for ecosystem partners to help them deploy builds at 25 megawatts a time. But they want that power in 2-week chunks. And that's fairly aggressive. But the principle that they're holding to is to simplify everything and standardize everything. And you can only start to say that once you truly understand what you've done in the past and what that means for the future. So if we look at eBay, slightly different model. They're also looking to standardize as much as they can. And their performance metrics is the cost of the transactions that they make. So it's not really a PUE number, it's how efficient per mouse click, per buy, can they make their kit. So they've taken a slightly different route by going very, very dense, high capacity racks, but they also measure total cost of ownership. So CapEx, OpEx is important, but their metrics is the cost of the service per click with total cost of ownership. So what does that mean in terms of a site? Well, here's a site in the desert in the US where gas is its primary power source. Why? Because as Rick said, their power grid is not that great. So they would rather have primary on-site power gen and the grid as backup. And the Nordics don't have that issue at all. They take another view of it's a fault-tolerant site, but the tier rating of the building, they'll go tier 4 where it's critical, tier 2 at the rack. Because what's critical is keeping the services and apps. So for them, that's the network. Go tier 4 on the actual net, making sure the traffic and service can move to another site is very important for them. And because they're in the desert, you would think, why are they building in the desert? Well, they've got 40 kilowatt racks, which is very high, PUE of 1.2, which is very, very efficient, is because they're designing for machines, not for people. And if there are any mechanical electrical consultants in the room and you're used to buildings for people, you would say the chilled water supply for the system should be 13 degrees C, eBay go for 30. The message here is the thinking is different, it's proven, the economic benefits are actually here. They're now. The future is here now. So when you understand everything, let's just simplify this a bit. That top pattern there is what a traditional data center would actually ask for. Single substation, various points of failure. But if you're saying, I'm moving to the Nordics, and I'm going to use this very strong grid, the 2 power feeds, it's not so simple, because you have to think about how am I going to get 2 grids to the site? How am I going to manage that in a failover issue? So if you speak to Rick, only because he's sitting at the front here, the ability to manage the grids, to make sure they're synced, that when you have a power down, that other grid is able to support the site, that's where simple means seek external device. Understand what simplicity really, really means. So what's actually happening now? I think there's two massive things happening now, and it's software-based. The network services are software-defined now. The ability to move the applications and services from rack to rack, from string to string, from site to site, from continent to continent are actually here now. The software-defined data center, the ability to manage your site from a desk, from an app, from a laptop, from anywhere, is actually here now. So it's moving into the automation of the data center industry. This commoditization, automatic, cheap, easy, quick, means that cloud now has the breathing space to grow up. And some of the triggers here are, if you want speed to market, you're probably going to choose a cloud solution. Data center capacity planning, if it's the 80-20 rule again, you're probably going to go cloud. And are you really going to refresh all that legacy kit and build the same old with very inefficient metrics? You're probably going to source a cloud model. So the question was, is a cloud data center a model for a design norm? Well, yes, because it is here and it's proven and it's simple. And we're certainly seeing clients move non-critical applications into the cloud, and we're seeing the service providers offering more of an outsourced model. And this is almost made for the Nordics. If I'm in Spain, I don't care if my email is routed and processed and managed from the north. I don't care if it comes from South Africa. Just as long as it comes. And if it comes with a really high latency speed of, say, 120 milliseconds, that is only a blink of a human eye. So the potential of cloud for the future is big. So where are we now? We're at a crossroads now. The new investors, established players, totally understand the new business metrics you can get from a cloud data center. But it's not for everybody. Some people want the steady state, they want to be in the city, they want a server hug, they see the IP is their IT infrastructure, or just maybe their particular enterprise isn't too IT intense. But the general message is, if you start to make something simple, totally understand it. And I take big store into that. If somebody can explain something very complicated in a very simple way, I always think they truly understand the subject matter. But it's probably taken them years to get to that point. Thank you.
1, 2. 1, 2.